Now we go to question number 9. Steam at 5 bar absolute with 2 to 5 degrees C of superheat is fed to a turbine at 1000 kg per hour. The turbine operation is adiabatic and the effluent is saturated steam at 1.013 bar. Calculate the work output of the turbine in kilowatt. Neglect delta EK and delta EP. Before that, let's go to the previous lecture notes where we have the energy balance for open system is delta H plus delta EK plus delta EP equals Q plus WS. Draw the flowchart first. Okay. So steam at 5 bar means this is steam five bar and 2 to 5 degrees C. And then the mass flow rate is M1 is 1000 kg per hour. Okay. The turbine operation is adiabatic, so Q equals 0. And the effluent is saturated steam. Okay, means the outlet. Okay, saturated steam. Before that, we know that the inlet is superheated. So this is superheat. Why we need to know the state of the steam? Because from the steam table later on, we need to look at either table B.6 or table B.5 or table B.7 to get the answer. The for inlet and also the outlet. And then we have effluent system at is 1.013. Okay, this is P in, T in. We need to calculate the output. Okay, of the turbine in kilowatt. We can neglect delta EK and neglect delta EP. If the energy balance for an open system equation or formula, we have this equation. Then delta EK, delta EP and Q is 0 from the question given. So we have delta H equals WS left for this formula. This term here, especially for change in enthalpy, okay, the unit for change in enthalpy is kilojoule per second. Then the one that we are going to use, the one that we will get from the steam table is specific enthalpy, which is kilojoule per kg. That's, if you realize here we factorize M from the formula here. Okay, why? Because if you look here, okay, M is kg per second, then times with specific enthalpy that we are going to obtain from the steam table, kilojoule per kg. Then we can cancel kg with kg. Left is kilojoule per second, which is delta H. Factorize M out from change in enthalpy here. We need to find the value of H in and H out. So we go back to the flow diagram. Just add one more variable here. We need to find the value of H in and H out. find the value of H in, we know the pressure and also temperature for superheat steam. So go to table B.7, okay? Table B.7, this one, for superheated steam, okay? So, is we look at 5 bar and also 2 to 5 degrees C. However, this is the value, okay? That means we need to add 2 to 5 with 151.8 to get the value of super. So if we add this, we will get 376.8 degrees C, where this is after the value of 350 here. So just write down here 376.8. Need to do value of H in from this steam table. Okay, first of all, we look at 300 degrees C. We have 3065 specific enthalpy. So we plot at the graph. For example, we use A to represent this point. So we have 300 and 3065. Then point B, we have 350 and 3168. So 350 and 3168. Okay, this is the axis for enthalpy, this is the axis for degree, the temperature. Then we need to do extrapolation because the value is more than 350. So we have the temperature which is 376.8, okay, this one, and then we need to find H in. So how to find? Initially we need to find the slope of MAB, where this is 300. We get 2.06, or it is equal to MBC. Next we have MBC equals H in, okay, H in minus 3168 per 376.8 minus 350, because we use B and C point. If we solve this part, okay, we will get H in equals to 3.3 kilojoule per kg. And for H out, pressure of saturated steam is 1.0131. That's why we look at table B.5, because this is for saturated steam. So we got the value of, okay, this is the steam, value of enthalpy, specific enthalpy equals 2676 kilojoule per kg. We already H out is this one. We can use plug in this equation to get the work output. Okay, so work output equals 100 kg per hour, where this is the mass now. Then this is H in, this is H out. Okay, then we convert the unit here, we get 152.2 kilowatt.